Hello students, welcome to Sir classes. So here in this video you can see that we are solving the UPSC 2021 this maths optional paper, and we have this paper 2. So this is question number 6C. It is given that obtain the Lagrangian equation for the motion of a system of two particles of unequal masses connected by an inextensible string passing over a small smooth pulley. So we have the figure over here. Okay, so then okay, this is the pulley, this inextensible string. Now we have this weight of unequal masses is that's told. So suppose this is mass m1 acting downward, and this is mass m2. Okay, so for here it is m1g and it is m2g, and suppose this length is x, this whole length is x. So it is, if we take this as, so let us take this body as p and q, and this distance is L minus x. Okay, so we have drawn this figure. So let the system of the two particles of unequal masses m1 and m2 connected by an inextensible string, you can see. So this is inextensible string passing over a small smooth pulley. So this is the pulley of radius r. So this is radius is r, and that is the both ends of the string are attached to the masses m1 and m2 respectively, right? So let the length of the string between m1 and m2 be L. So then from the figure, so this is point A. Okay, so from the figure you can get that PA is equal to x and QA is equal to L minus x. So the system has only 1 degree of freedom. Okay. So and x is the only generalized coordinate. So this is the from the figure. So we have to find the Lagrangian equation. So the instantaneous configuration is specified by the, if we write the instantaneous configuration, so it is specified by q equal to x. Okay, assuming that the cord doesn't slip, the angular velocity of the pulley, it is x dot by r, x dot by r is the radius of the pulley. Okay, so hence the kinetic energy of the system will be, this kinetic energy of the system is given by, this is T is equal to half of m1 x dot square, or x prime you can say, plus half of m2 x2 dot square. Okay, so this is not x2, so just I have given the x, that is the length of PA. Okay, and this will be plus of I of x dot square by r square. Okay, so the potential energy of the system, the potential energy of the system, it is given as v equal to minus of m1 gx, sorry, it is m1 gx and minus of m2 g l minus x, right? So and the Lagrangian will be, so from here we will obtain the Lagrangian, so that is L equal to T minus V. So what is T? Write the equation of T. So that is half of m1 plus m2 plus I by r square of x dot square, and it is m1 minus m2 g x plus of m2 g l, right? So if we do the first derivative with respect to dot l x x prime by x dot, you can say, so that is m1 plus m2 plus I by r square multiplied by x, and this del of del x is it is going to be m1 minus m2 g. Okay, so this is going to be 0. So now we have got the Lagrangian equation from here. So the Lagrangian equation of motion, so it will be d of dt of del L del x minus, it is del x dot minus of del L del x 0. So it will become, so if we take this ddt of, so del L del x is del x dot, it is m1 plus m2 plus I by r square, right? So whole multiplied by x dot. So here I have missed this, so it is x dot or x prime, you can say. So here is the x prime. Okay, so minus of g multiplied by m1 minus m2, that will be equal to 0. Now we can write this as, so ddt of this m1 plus m2 plus I by r square x dot, so it is simply, it can be written as m1 plus m2 plus I by r square x double dot equal to g of m1 minus m2. So from here you can find the x of double dot or x double prime, this is the equation of motion, that is equal to g of m1 minus m2 by m1 plus m2 plus I by r square. So that is the equation of the motion. Okay, so that solves our last part of the question 6. So in the next video we will see with the start with this question number 7. Okay, so see you in the next video.